What's up, everyone? So, as you can notice, my voice is back and I'm actually got fully recovered. So, let's jump into the math part. This, perhaps you have already noticed, is actually I made a video, a short video, around 3 months ago that I want everyone to take a guess or try to figure out what's going on here. But I noticed most of you actually didn't answer at all, or perhaps you just couldn't figure out. So today I decided to go over these problems and then trying to guide you all what basis these modifications are. So before we move on, if you didn't watch that short video yet, you can just click the link below in the description and you can go to check out that short video. And of course, you can also try to figure out yourself before coming back and see the solutions. You ready for it? Here we go. So first, let's take a look at all these 6 modifications. One of them is actually a regular modification that we have already know, which is the one here. We know that 24 times 6 is 144, right? So first, this multiplication is a regular multiplication, meaning that all the numbers that we have are actually in our common base, or base 10. Okay? If you don't remember or don't know what base 10 means, or some other different bases, go check out my few of my early videos. I have a complete explanation of what different bases are. So you can just figure it out first and come back and try to guess what these are. Good. And then in my short video, I also mentioned that this is base 6. So the first calculation or the first multiplication is in base 6. And again, how do we know that we are actually in base 6? And how do we figure out which base each multiplication is? Here is what we're going to do. First, we said this is base 6, so let's double check our work. How do we do in base 6? We're going to make a multiplication table. So let's make it on top here. And I'm going to skip the rows and columns of 1 and 0 because those are easy and we should all know what to do. So I'm going to start with 2, and then I'm going to list out the remaining 4 numbers, 2, 3, 4, and 5. Then we're now going to do the multiplications. So 2 times 2 is of course 4, 2 times 3 is 6, 2 times 4 is 8, and 2 times 5 is 10. But again, we're now in base 6. If this is true, then we need to convert those numbers that are greater than or equal to 6 into another expression in base 6. So, for example, 2 times 3 is 6, but 6 is 6 times 1. So, according to the representation of base 6, we have to write 6 into 1, 0, meaning that we have 1 copy of 6 times 0 copy of 1. Not times, excuse me. 1 copy of 6 plus 0 copy of 1. Then we're going to move on and get 1, 2, and 1, 4. Again, these numbers are not the regular numbers that we, regular representations that we usually have. So do not read it as 10, 12, or 14. Those are not representing 10, 12, or 14. So if we continue our multiplication table, we'll get something like this. 2, 0, 2, 3, and so on and so forth. And then we can now just check our calculation. So we have 4 times 2, which is 8, but in base 6, the representation is 1, 2. So we will put the 2 here. So this is checked. Good. And then of course the 1, just like regular multiplication, we need to carry the 1 to the next digits to do the addition. Then we have 2 times 2, which is 4, plus the 1 that we just carried, we get 5. Therefore, this is indeed in base 6. Now, for the rest, I am going to show it two ways. First, I'm going to do one way, which is to check after we guess. So here, let's take a guess. This is base 7. Now, why would I guess this is base 7? I don't know, because this doesn't look like they're all in the same basis. And when I decided, of course, I tried to make it in an increasing order. So we can see that this is base 6, 10, so we have 7, 8, and 9. Probably, okay? But of course, we need to check it and verify our answer is correct. So how do we do it? Again, this is the first method. To verify whether our guess is correct, we can just think of our multiplication table. So we're now doing in base 7. So again, we have 3 on the bottom, so we're going to do the times 3 here. So we can just do something like this. So again, we can start with 0 or 1, but here we know that 0 times 3 is 0 and 1 times 3 is 1, so we can just move on. And notice that when we think of 0 and 1 as one of the terms we're going to multiply with, we will always get either 0 or the number that we're multiplying with as the result. And since we're now thinking of single digits, we will always get that single digits back, and we don't have to worry about the base, no matter what base we're using, because that number is of course less than the base number. So that's why we can just start with 2 here. So 2 times 3 is of course 6, and 6 is less than 7, so we're good. Then 3 times 3 is 9, but since we're in base 7, again, how do we convert it? To figure out the expression, we're going to take a long division. So 9 divided by 7 is 1, and then if we do the subtraction, we have remainder 2. So our last digit is 2. Next, we have 1. 1 is already less than 7, so we're good. We can just put that remainder 1 into our next digit. So again, we can just do a long division one more time. 1 divided by 7 is of course 0, because 1 is already less than 7. Then what is the remainder? 1. So we just put that remainder in our next digit. Good. So we have the expression 1, 2 as 3 times 3. Then 3 times 4, we can just do a long division one more time. But again, when we say multiplication, it is the same as saying repeating addition. So we're just adding another 3 from whatever we already have. So if we have the expression 1, 2, and we're going to add 3 on it, we'll just have 1, 2 plus 3. And when we do the addition, it's just the same as the regular addition. So we have 2 times 3, not 2 times 3, 2 plus 3, which is 5. And then we just bring down the 1. So we will get the expression or the representation 1, 5. So this is all we need, because we have 2 times 3 and 4 times 3. And we already get what we want. So let's move it and check it. So 4 times 3 is 1, 5. We see that we have a 5 here. Good. Then don't forget we have to carry the 1 to the next digit. So now we're going to do 2 times 3, which is 6. And plus 1, we will get 7. But since we're in base 7, we will write 7 as 1, 0. Good. Excellent. So for the rest, let's write down the answer first, and then we'll go over the second method. Okay, so now we claim that the rest of the answers will be base 8, base 9, and of course base 10 we have already confirmed it, and base 11 for the last one. Then now We already checked this, and of course, this one. So how do we verify the other three answers that are correct? Here is a second method, and I'm going to do it with the last answer as an example. And for the remaining two, base 8 and base 9, I'll leave it as a homework assignment for you guys to think of. So here is the second method. As we already know that the previous one is base 10 with the expression like this, 144. And we also have base 6 and base 7, and we actually have a pattern that we're seeing that we jump from 2 to 5 here, and at the same time we have 5 to move to 1 0. So what are we going to do? Well, here is the trick that we are going excuse me. Here is the trick that we're going to use. So notice the pattern here. We see that the last digit is going to add 3 at first, but then afterwards, after we move from base 7 to base 8, well, we're going to start adding 2 instead. Okay, so from here we have the last digit 4, and for the next one we have the last digit, which is 6. Then we are going to guess that the base is going to increase by 1 only. Why? Again, we're supposed to add 4 on it. But then, now instead of adding 4 to the digits, we're adding only 2. What does that mean? Well, it means that we now need to guess why we have to, why we are only adding 2 on the last digits instead of adding 4. Okay, and we're going to guess why, how much we're actually adding in the base in order to change it. So again, if we think of the regular calculation, 24 times 7, then in base 10, we of course put an 8 here, and then we carry the 2, and then we get 168. Okay, but now we have 156. Why? Notice that for the last digits, we have 2 less. And for the second of the last digits, we have 1 less than what we should get. So we actually can see that there has to be a pattern. And we see that it has to, it will be increasing by 1. We're increasing the base number by 1 so that we'll actually have a shift here. Good. And that's how we can actually quickly check or guess what the base of the different calculation, different multiplication is. So yes, that's pretty much it. And again, for the remaining 2, I'll let you guys check it yourself. You can use either method to verify whether the answers are correct or not. So I hope you enjoyed this video. If you think this is pretty cool, don't forget to like and also subscribe to my channel so that you can find out more of my other videos, and also turn on the notification bell so that you can always check my new video whenever it's uploaded. I'll see you guys next time.